Hey, welcome to the podcast for Chapter 6 on measurement. The overall goal for this chapter is to give you guys an idea of how we go about measuring things in quantitative research methods. So, we'll go over some of the basic definitions and principles, and then spend the time going a little more in depth into the concepts of reliability and validity. All right, let's go ahead and get started. All right, so first the basics. When we talk about measurement, you have to know that we're primarily talking about the tools and techniques associated with quantitative methods of research designs. When we do qualitative research designs, we do things a little bit differently and we're more interested in that holistic view, however, not so much with quantitative. So, inside quantitative designs, everything that we measure is done through numbers. And for us, in this methodology, numbers are useful because they give us a way to identify and understand information. However, as we'll cover later, there's nothing inherent about those numbers. We assign those numbers, but then that allows us the ability to run statistical tests and so on. Through this process, it builds a bridge between the conceptual ideas that we have when we put together our variables, as well to the empirical phenomena that we're observing inside our research studies. And the key thing here is that it's just really necessary to conduct quantitative research. If we weren't able to break things down into numbers and measure them, we wouldn't be able to do this type of work. All right, so some basic principles. Just go ahead and starting off with a definition of measurement. Keaton defines measurement as something that allows us to describe whatever we measure in some standardized form, and also allows us to evaluate what it is we describe. So here, when we talk about the value we assign to numbers is not inherent, but it's something that we've given to those numbers. So it's kind of useful to think as measurement as a process that can include everything that the researcher does to arrive at their numerical estimates. Um, the measuring device or instrument. So when we talk about a measuring device or instrument, we're interested in how that instrument is used. And a bunch of different things go into that. So when we talk about the numbers inside our study, numbers can measure a lot of different things based on the instruments that we have. So we can have instruments that measure values, intensities, the degree to which something happens, depth, length, width, distance, and so on. Um, it's important that we do this because it provides us with a series of descriptive um, and evaluative devices. So we're going to talk more today about the different types of tools that are out there, but primarily through these instruments, we're able to gain understanding um, and do that. So with our numbers, as I mentioned before, they have no meaning until we provide meaning. Having an instrument is a way to go ahead and ascribe meaning to that. Um, all right. So the key idea, if you find yourself reading a quantitative study or doing quantitative research, is look for the operationalization of a given variable. When a researcher operationalizes a variable, that's where you're going to find the definition of what instrument they used and how that variable was ultimately measured. Remember, we've broke variables down into different areas, and we can see how we might measure something different based on that. It's important that our measurement is accurate. It's really the foundation of statistical analyses as well as the subsequent interpretations made by the researcher. If somehow our measurement is flawed, then everything associated with that measurement um, can be flawed. All right. All right, so levels of measurement. So when we consider the levels of measurement, there are two types of data that we see: discrete and continuous. I'm going to explain what both of these are, but at the outset, it's important that you know one, that both are representative of types of phenomena that we study. Two, each produces a different type of data, and three, ultimately how we collect data determines how it is used in statistical analysis. So let's go ahead and start with discrete data. So discrete data represents the presence or absence of some sort of characteristic. This is known as nominal or categorical data. Nominal data must have at least two categories. Responses are usually in the form of categories. So things like political affiliation, where you could be a Republican, a Democrat, a Green. Are there still Greens? Or something like sex, male, female, class levels, employment status, and so on. Usually, when we talk about this type of data, we're talking about demographic information that we have on our surveys, and it's the way we go about correcting that. So, representing different types of information, but not necessarily differing amounts of that information. It's also important to remember that categories do not possess any inherent value, right? If I'm doing a survey and I want to ask my respondents whether they are male or female, I might assign a 1 to male and 2 to female. However, there's no inherent value. So like running statistical tests on that for the most part isn't going to tell us anything because I've just arbitrarily assigned those numbers to that. When we have categories, there's a couple of rules about categories. First, categories must be mutually exclusive, i.e., a respondent cannot fit into more than one category. They got to be exhaustive, so all of the categories that you represent need to represent the full range of categories relevant to the information that you're collecting or that exists. But they also need to be equivalent, need to be equal to one to another. It wouldn't make sense to have categories that are about different things. And so you need to make sure that they all fall into that. And like I said, primarily talking about demographic data in this example. All right, continuous level data. We talk about continuous level data. We're talking about variables that take on or assume a quantity, intensity, or magnitude. The values can differ in degree, amount, frequency, and differences can be ordered on a continuum from minimum to maximum quantity. When we talk about continuous level data, there are three types of data that we talk about: ordinal data, interval data, and ratio data. And I'm going to take you through all of these next. All right, so ordinal data. We talk about ordinal data. What we're talking about is ranking items in order from high to low or low to high. The ordering suggests that there is some sequence to the value of the data. Ranking positions is only relative to other ranking positions inside that group. The distance between ranked elements is uneven and often even unknown to the researcher. Because ordinal data consists of relative rankings, zero cannot exist inside ordinal data. Interval data. Interval data is measured based on specific numerical scores or values. We can identify which participants scored highest and which ones scored lowest. We can determine exact difference between and among the scores. Acknowledgement of zero, although even though we acknowledge it, it's still arbitrary in that sense. Responses are often totaled across items to create a score or a total variable. The scores are then averaged, and we're able to determine what the mean score is to represent the entire sample. And we often gather this information through either Likert type or semantic differential type scales. All right, ratio data. Ratio data is similar to interval data, except zero is absolute, i.e. the variable does not exist at all. So when we measure that zero, that means there's a complete lack of that variable measured inside of it. So it needs to be obviously a variable that could have complete absence inside of it. Intervals between data points are always equal. If a score is zero, then there's a complete lack of the variable. It's really not that common in communication research. When it's used, it provides measurement of the degree to which something actually exists. So, for example, counting the number of times patients ask questions to their doctors or the length of an interaction could all be examples of ratio data. All right. Now that we've covered the basics of measurements, let's spend a little time talking about reliability and validity. All right. So what we're really talking about here is the scientific process again. And inside the scientific process, there's a requirement for researchers that we make sure that we provide both valid and reliable measurements in our research studies. When we have measurements that are not valid or reliable, ultimately, then those measurements are incapable of helping researchers answer their research question or confirm or reject hypotheses. So measurement validity and reliability becomes central to the research process. And I'm going to take you through each of these and give you some examples to help you understand this better. All right, validity. So first off, just a definition for you again. Keaton defines validity as the extent to which something measures what you want it to measure. So for example, the characteristics in your research question or hypothesis, and so not something else. So really what we're trying to do here is making sure that inside validity that we're actually measuring what we're setting out to measure and not some other phenomena or variable that might be similar but altogether different. The validity really speaks to the accuracy of the measurement. It is also a matter of degree in communication research because often we cannot directly observe what we want to measure and have to infer behaviors we can reserve. So, couple types of validity that are worth mentioning. First, off the top, we talk about internal validity. This really addresses the relationship between the concept being measured and the process measuring it. So just kind of keep that out on the outset. Now we can break down a little more into the specific types of validity. All right, so face validity. We talk about face validity. The items reference the construct that we want to measure inside of this. Face validity is often the easiest type of validity to establish. However, it is also the weakest type. As researchers, we can strengthen face validity when we use experts in the content area of the measuring instrument to assess its viability in capturing the construct of interest. All right, second key type of validity worth talking about is content validity. So content validity is the degree to which items in the measuring device represent the full range of characteristics or attitudes associated with the construct of interest. So in other words, the measuring types or excuse me, the measuring items are representative of all items potentially available. Criterion related validity. Criterion related validity is achieved when one measurement can be linked to some other external measurement. It can also be achieved through two procedures, predictive validity and concurrent validity. So concurrent validity is the degree of comparison on scores of a given variable from a new and established measurement when the measurements are administered concurrently. The comparison is achieved through correlation and should be highly related. Predictive validity. When we talk about predictive validity, this is the degree to which participants' responses to a questionnaire will in fact predict their communication behavior. So Keaton gives a bunch of examples that are worth checking out, but I'll let you guys go ahead and look at those in your own time. All right, and then finally, construct validity. Construct validity. This is used to establish that researchers are measuring the core concept that was intended to be measured and not something else. So often researchers use a different measure of the same or similar phenomena to establish construct validity. Construct validity rests on the arguments and supporting evidence provided. They are consistent with theoretical explanations. Construct validity is theoretically based because one measurement is related in a theoretically meaningful way to another meaningful measurement. So in one example in your textbook, the authors compared results when data were submitted to two very similar coding schemes. And this is on page 109 in the third edition. And as expected, the two coding schemes produced highly similar results. In the second example, the authors established the construct validity of the connected classroom environment, and this is basically how students perceive supportive and cooperative communication from other students in the classroom. And by correlated results with that of a measure of classroom engagement, as expected, they found a positive relationship. So you can see how those similarly theoretical ideas that they were able to put out there went in the same direction. They were able to connect those concepts together through that. Okay, so when we think about validity, you really want to think about validity as something that captures the, essence of something. So moving closer to capturing the reality or true nature of the phenomena being studied ultimately improves the validity. Thus, validity is something that is developed over time. When a measurement is valid, it ultimately becomes truthful and accurate to the empirical phenomena that we're observing. All right, let's go ahead and move on and talk a little bit about reliability. All right, so reliability. Um, the reliability of a measurement is its degree of trustworthiness, dependability, stability, and so on. If a measuring device varies randomly, there's going to be a greater amount of error, and ultimately the reliability will be lower. Consistency is another word often used to describe reliability. So a reliable measurement is thus consistent in that it gives similar results each time we use it. So how is reliability expressed? Reliability is expressed as a matter of degree because some degree of error is always present in the research that we do. So rather than use phrases like completely reliable or not reliable at all, researchers depend on what is known as the reliability coefficient. And there are a few different types. The main one that we'll be using in this class is Cronbach's alpha. So when we talk about the reliability score, it's something that is expressed between the number 0 and the number 1. The closer the reliability coefficient is to 1, the greater the degree of reliability. And vice versa, the closer it is to 0, the less reliable it is. So I guess the key question is, what is reliable enough? So it can vary a lot by discipline, but in communication, researchers typically agree that a reliability coefficient above 0.70 is acceptable. This is the commonly accepted standard, but again, it's not an absolute. If the construct is easy to measure, e.g., something like communication apprehension, then a reliability of coefficient above 0.80 or greater is expected. If the concept is difficult to capture and thus measure, so something more abstract, then a lower reliability coefficient could be acceptable. So there are three kinds of reliability associated with questionnaires and surveys: internal reliability, test-retest reliability, and split half reliability. And I'm just going to briefly take you through those because I think it's worth just briefly talking about here. So internal reliability. Internal reliability is the degree to which all of the items are measuring a concept invoke the same response from a person measuring it. It's not likely that any questionnaire will result in perfect reliability because of a variety of different sources of bias and error and so on. So the question or item itself might be ambiguously worded or may contain a word with participants that are like unfamiliar or invokes specific feelings. Participants' experience or frame of reference might cause them to interpret the question differently from what you as a researcher intended when you wrote it. Um, Also, where and how the participant takes the survey can affect the responses. So example, if the participant feels rushed because of a late arrival to the survey, or the room is too cold or dark or has annoying buzzing lights, all of those things can ultimately impact your reliability. Um, Sometimes too, participants' mood may influence responses. So if they had a really bad day or they had a hot date that night or something like that, that might impact their responses in your questionnaire. The participants' interaction with the researchers can also affect how honestly the participant will respond to the questionnaire. If they have a lot of interaction with the researcher, it may jade and influence the way they take it. The participants' familiarity, excuse me, the participants' familiarity with the questionnaire can also affect the consistency of the responses. So, for example, if they filled out it previously or they took another study that used a similar questionnaire items, they may not look as closely at the items as they should and may misanswer some questions. So, as the researcher, you should try to control as many of these sources as possible in such ways as pre-testing and your instrument to see if there are any problems, control how you interact with your participants, and just try to ultimately have control of these variables as you go throughout it. Um, all right, so reliability of any measuring instrument that includes multiple items, 3 items or more, should be calculated each time the instrument is used. So we have statistical programs such as SPSS that make it really easy for us to calculate this reliability, at least compared to what it used to be like pre-statistical software. The test that we run in this class, as I mentioned, is Chromevox Alpha. And that tests the internal reliability or internal consistency of the items. The statistic it produces is called the coefficient alpha. The alpha for each variable is reported in the method or the results section of the research report. Recall that researchers generally agree that the coefficient alpha of 0.70 or greater is sufficient for establishing internal reliability of a measuring instrument. If the internal reliability of a measuring instrument is not sufficient, the variable may have to be dropped from further analyses. All right, so ideally the coefficient alpha would be calculated and reported for each variable operationalized within a multi-item instrument. So again, an example on page 112 of the third edition has an instrument measuring the subjective norm that has achieved a reliability of only 0.61, and thus readers of the research study knew to be cautious when interpreting results associated with that variable. Journals to which researchers typically submit their research for publication may determine that authors must drop a variable from their study if their measurement does not achieve a 0.70 coefficient alpha or agree not to publish the study at all. All right, so reliability between the coders. So consistency of measurement is also an issue when two or more research or coders code elements into nominal categories. This is a technique that is known as content coding. When there are several raters or evaluators, the measure of reliability is known as inter-rater reliability, inter-rater agreement, or inter-coder reliability. This type of reliability should be reported when two or more coders assign communication behaviors to categories, or when two or more raters evaluate some communication act on a scale or index. So there are two types of inter-relator reliability. First, unitizing reliability, which is the degree to which two or more observers agree that communication action has taken place and can identify the action in the stream of interaction. So basically, do the coders agree what is to be coded? Units can be small, so for example, phrases, sentences, or larger. A lengthy turn at talk, or say like a news story or something. Unitizing requires raters to identify the beginning and ending of what they will code. All right, so the next is categorizing reliability. And this happens after units are agreed upon, and it entails discriminating among them by assigning each unit to one of the available categories. And this really captures the degree to which multiple coders make similar distinctions in assigning data to categories. There's another concept that we won't really be using too much in our studies, but it's important to understand, that of Cohen's kappa. And this is the measure of inter-rater reliability for categorical data. And this, again, can range from perfect agreement at a 1.0 to agreement that is no better than would be expected by chance, a 0. So for coding the message function or categorizing reliability, use Cohen's kappa. Intercoder reliability should be computed for each decision point along that process. All right, so the next type of reliability to talk about is test-retest reliability. So when we think about communication, it's an interaction process, and over time, interaction or our perceptions of it can change. Thus, many researchers design their studies to capture measurements at different points in time, sometimes to demonstrate the stability of a measuring instrument. Test-retest reliability captures the relationship or correlation between scores at two administrations of the same test or measurement to the same participants. So here, a 1.0 would indicate that the same participants evaluated the stimulus the second time exactly as they did a first time, whereas the score of 0.0 would indicate that there were two measurements or no better than that by chance. Test-retest of interval data is calculated with Chromevox Alpha. All right, split half reliability. So occasionally, researchers need to use split half reliability, especially when they need to test knowledge. So, example, testing knowledge of public speaking principles before and after some sort of training to get better out of it, i.e., taking a CMST 131 class. So here, using the same test at the second testing might artificially elevate their scores because participants might remember their responses from the first test. To avoid this type of bias, the researcher would want to construct one test that then she would split into two separate parts. This would result in two separate but equal versions of the same information. Thus, they'd be able to compute the correlation or the split half reliability between those two test administrations, and that would indicate a degree of consistency between them. All right, so finally, some things that you can do to improve reliability. So, ways to improve. First off, poorly worded or confusing items on a questionnaire can easily be rewritten. You can also give better instructions that can be given to your respondents. Researchers can take steps to make sure that all measurements occur under similar environmental conditions, i.e., having to take place in the same lab or same environment, same classroom, and so on. Before working with the data, collected for the research project. If you have raters, they can be trained on similar data until they're able to reach consensus on how to unitize, categorize, and evaluate the interaction. And then if similar data are not available and the study generated plenty of data, researchers can select out of a small portion of the data to use for that training purposes. Keep in mind that reliability is subjective, right? You must decide what is acceptable to you as a consumer of research and as a researcher. When measurements are not reliable, the findings or conclusions based on them are not warranted and defendable, so it becomes highly problematic inside our research studies. All right, so the relationship between validity and reliability. So, developing a measure that is both reliable and valid is difficult. Although reliability and validity are two separate concepts, they are connected in a very functional way. One, measurement and questionnaire should both be reliable and valid. Two, reliable measurement can be obtained even if the measurement is not valid. So, for example, it can be consistently measured, can consistently measure the wrong thing. Three, valid measures are useful only if they are also reliable. So when validity is achieved, reliability is assumed. Thus, validity is primary of the two. So then validity is often more difficult to achieve than reliability. As you find yourself reading research reports, you should take careful note into the way in which reliability and validity information is presented. Each researcher ultimately makes judgments about the reliability and validity of his or her data. Each consumer must also make judgments. Are the data reliable enough for you to accept the conclusions based off of those? And so I often find the best way to understand reliability and validity is the target metaphor. So if you look at the series of targets, it can help give you an idea. On these targets, each bullet hole we'll say, represents an item on a questionnaire, on a study measuring a given variable. So say something like communication apprehension. If we look at the items on the first study, here on the left, the one labeled reliable, not valid, we can see that the items seem to be measuring the same thing. However, they're not valid, even though they measure the same thing. It's not hitting the bullseye. We move over to the second option here, where we see valid but not reliable. We see that we're hitting all over the same idea and concept. However, there isn't enough consistency between the items to say that the data is ultimately valid. We usually wouldn't see something like this because there's no way for us to really tell that they're all valid, but nonetheless, that might be an idea of what that might look like. If we have something that is neither valid nor reliable, again, as we see in this third example, we're not seeing the items grouped very closely together, and they don't even seem to be hitting the target. And so the goal, what we really want to see inside a study, is for something to be both valid and reliable, where again all of our our items are closely grouped together, thus consistent, but also hitting the bullseye of our target. All right, so some common threats to validity and reliability. So a threat is any data related problem that could potentially lead you to draw a false conclusion from the data. Both participants and researchers can contribute to these problems. So first, issues of data collection. Self-report surveys can be problematic. Some measurement instruments ask you to think of how you behaved in the past or in a particular communication event. There could be a good deal of difference between how you actually communicated and what you remember about how you communicated. This represents the threat to internal validity or the extent to which conclusions can be drawn from the data. Two, dated instruments are often problematic, and there are some instruments that have been established to be valid and reliable, but are also very old. So this is especially true of instruments that measure communication and relationships that reflect changing social values, e.g., like marital relationships and things so on. Marriage in the 1950s was very different after the 1960s with the Cultural Revolution. This is also a threat to internal reliability. The researcher can also cause threats to internal validity. So the researcher's characteristics or unknowing behavior. The researchers unknowingly influence how participants behave and respond to stimuli because of their sex or communication style. The researcher can unknowingly use nonverbal behavior such as nodding or smiling at their respondents. This might confirm or disconfirm what he or she expects to find, thereby leading the participant to a particular type of response. These problems can be limited by the person collecting the data not knowing the hypotheses or the research questions. So you might have a lab assistant or something collect the data for that. Two, there's also variance in research judgment. So varying judgments about what they are actually observing. This can be caused by things such as fatigue, boredom, and this also threatens internal reliability. There are also a variety of ways that the participant can threaten internal validity. So first off, morality or attrition. This means that the membership in the group can change. You might have people that lose interest or motivation to take part in your study. You also have maturation. Here, the participants change or mature over time. Over the course of the observations, their attitudes and beliefs might change, or they might become very familiar with the same questionnaire. And so all of those things can threaten internal validity. All right, so sample representativeness. This is a threat to external validity. So the use of non-probability samples weakens the generalizability of your findings. So a big example of this that we commonly see in research is the use of university students as a sample who really only reflect a population of university students across the country and around the globe. Lab experiments can also be a threat to external validity because people may behave differently when they're not in a controlled environment. So whenever the results for other samples and populations are not known and it may be different, we will infer to as threat as ecological validity, which is another form of external validity. So, all right, so a few alternative explanations before we move on. Researchers cannot consider every possible alternative when they design a research study, but they should consider all plausible explanations for the results they find. Researchers hope that the effects they find are all due to the communication phenomena they studied, but they should look for alternative explanations and give the reader arguments and evidence that what they find and study is truly responsible for the conclusions that they draw. It would ultimately be unethical for a research team not to consider alternative explanations. All right, so issues of data interpretation. Researchers who use number in their data collection are responsible for collecting data accurately and ethically and interpreting and reporting it responsibility. Most people who read research reports will take these actions for granted. Most consumers of research will not question what data collection method was used or why, nor will they question how the researchers interpreted the data. So As a result, data interpretation is intimately linked to the data collected, i.e., the quantity of the interpretation cannot be better than the quality of the data. Data are also intimately linked with the theory or premise of the study. Thus, measurement is central to the quality or outcomes produced. Questions consumers might ask about how the data collected would be along the lines of, do you agree how the variables were operationalized? Were the data collection instruments valid and reliable? Did the researcher collect data in such a way that he or she expected to find, or what she or she expected to find became overemphasized and obvious to the participants? Um, were the researchers' expectations communicated unknowingly to the participants in any other way? Were the data collection procedures consistently applied? Do these data make sense given the research questions or hypotheses presented? Questions consumers might ask related to the interpretation of the data might be one, did he or she draw sweeping conclusions from non-representative data? Did she or he accept all data results as firm conclusions without examining alternative interpretations? Did he or she adequately explain contradictory and anticipated findings? Did she or he oversimplify the negative or inconclusive results without looking for weakness in the research process? So, like an incorrect theory or hypotheses, inappropriate methodology, poor measurement, faulty analysis, and so on. Okay, so as communication researchers, remember that your role is an active one. Ultimately, it's our job to think through the presentation of how the data were collected and analyzed. Also, we should test what you believe it means against what other researchers say it means. So, some important questions that go along this: what questions did that researcher ask? Um, how much confidence do you have in the data collection methods and statistical analyses used? What did the researcher find? What meaning did the researchers infer from those results? How do the interpretations fit with the question asks? And do you agree with their conclusions? Um, so, do the conclusions fit with other known information about the issue or subject? Is there anything missing that might be important? And overall, who do those to whom do those conclusions apply? All right. Well, that kind of wraps up measurement in a nutshell. Thanks for your time.